we need to meet a new functional group. In fact, two new functional groups. Meet new FGs. And these are going to be the acetals and ketals. Okay, so we have seen, let's show an aldehyde right here, and let's show a ketone down here. So here's the aldehyde series, and over down here is the ketone series. So we saw in the last video that you can add things to a carbonyl like an aldehyde or ketone. So let's see some of the possible outcomes. If we were to add water to an aldehyde, we get something called, not very creatively, the hydrate. And all we've done is added water. So I say added water. I mean, that's a very precise verb. We've done an addition. We've broken a pi bond and made a sigma bond. That's what we did. We added water, literally, to this molecule. In the top case, an aldehyde. If we do the same thing for a ketone, we also make a hydrate. It's the hydrate of a ketone. We get that by adding water. Now, as it turns out, you can also add alcohols. Alcohols can attack, and that's what we saw in the previous video, which introduced this idea of acid-catalyzed additions. I'm going to make that R double prime. So when we add an alcohol to an aldehyde, we get something called a hemi-acetal. Hemi-acetal because we get an OH on one and an OR on the other side when we do this addition. So what we've done is we've added an alcohol. No surprise down below, we can also add alcohols to a ketone. And so we get a hemi. It's not going to be an acetal, it's going to be called a ketal. And again, here we are adding an alcohol. Now, last but not least, we have a fourth option. And that's to get something that looks like this. Now, and actually these two alcohol groups, these two OR groups, do not have to be the same, but I'm going to, just to simplify things, we're going to show them as the same. This is not a hemi-acetal, this is now a complete acetal. And to get to here, we had to add 2 of our alcohols, and we had to lose, that OH had to be dropped. So we also had to lose, if you go through atom-wise what happened, we have to lose 2 waters. Down below, we're going to finish the picture, and you can guess at what we'll see. This will not be a hemi-acetal or a hemi-ketal. It will be a complete ketal. And again, what do? We add an alcohol. We had to do that twice, and somehow in the process we had to lose water. Now, you may look at this and think, there's no way I want to memorize this. This is confusing. Don't like it. Please make this video stop. But I want to put some ideas out. One, all these have the same oxidation state. So these are not so different. So how do we determine oxidation state? We look at and I'm up here on the aldehyde. How many bonds to an electronegative atom does that carbon of the carbonyl have? It has 2. All of these, this central carbon, as I go across the top line, that central carbon has 2 bonds to an electronegative atom. So we haven't changed oxidation state. All we've done is done conversions within an oxidation state. Second, all this chemistry uses the exact same mechanism. And it's an acid-catalyzed mechanism. So even though these look different, yes, they are different. They have different names, but they interconvert through exactly the same chemistry. So even though they have different names, functionally, they are almost identical. So instead of focusing on how they're different and trying to make this slide into 8 boxes, and put these into compartments. Keep in your mind that all of these are completely and intimately connected.